Okay, we're going to begin Lesson 30, which is Unit 5.8, page 327 in the book Law of Cosines. But before I get into that lesson, I want to do some review of what we've talked about so far, because we've talked about angle, side angle, and angle, angle, side, and a lot of those things, and what do you use when what you're given is in a certain order. And I've given you a sheet that summarizes this, but I just wanted to have it on video also. If what we're given in a non-right triangle is the order of angle, side, angle, or angle, angle, side, we use the law of sines, as you said, the law of sines. And what is the law of sines? Sine of angle A over little a is equal to sine of angle B over little b, which is equal to sine of angle C over little c. And so we just take off. How many answers are there going to be if what you're given is in the order angle, side, angle, or angle, angle, side? Only one answer. We know there's going to be one, and we know there's only going to be one. And so right here, there's one solution, or one distinct triangle that could be created with that given information. If what we're given is in the order side, side, angle, how many possible solutions do we have? 0, 1, or 2. And we call this the ambiguous case for the law of sines. The ambiguous case for the law of sines. Now, we said instead of trying to learn all those rules to figure out if there's 0, 1, or 2, we're just going to act like there's 2 and start solving. And it's going to return, when you do sine on the calculator, the smallest answer choice, right? And so what's going to happen is when you do sine, this is important for you to know, you're going to find the smallest angle first. Now, the reason that that's important is sine is positive in quadrant 1 and quadrant 2. So there's going to be 2 angles that have the same arcsine value. Okay? And we wouldn't know if it was the one in quadrant 1 or 2, but we do know if we did it on the calculator, it always returns the smallest. And if we're choosing in our brain, we're always going to choose the smallest first. Okay? We're always going to choose the smallest first. So if the sum of our angles gets to be bigger than 180, we know there's no triangle. That's how we don't have any, or we don't have but one, or we do not have but one, or we have up to 2. Then when we got to area, we know if we know base and height, we can go 1/2 base times height. Or if we had a right triangle, we could do some Pythagorean theorem stuff or some special right triangle stuff, and we could probably, because of all the stuff we know about right triangles, go ahead and find the area with 1/2 base times height if we do some manipulation. But if we have non-right triangles and we don't know base and height, then we would not know how to find the area without these additional formulas. And so then we learned that we can find the area of a non-right triangle if what we know is in the order of side, angle, side. And the formula that you use in that case is K equal what? It's going to be equal to 1/2 BC sine A. Now, the BC are these 2 sides. You realize that. And the A is that angle. So you will be given 2 sides and an included angle. So it's the area. We use K because big A is that angle right there, see? So we're going to say, or it's actually angle A. But anyway, we're going to say K for area is equal to 1/2 BC sine A, where B and C are those sides, and A is that angle that was included between those sides. So it could be 1/2 AB sine C, or it could be 1/2 AC sine B. You realize that, okay? Then if what we're given is in the order of angle, angle, side, then my formula is K is equal to 1/2 B squared sine A sine C over sine B. Now, in this case, what the situation is that this angle and that side are opposite each other. I'll just try to draw you a little picture here. If I had angle, angle, side, do you see that in angle, angle, side, that side and that angle are going to be opposite? So whatever side this is going to be right there, and the angle opposite is going to be the one on the bottom. The angle on the bottom is the one across from that side right there. So this could be 1/2 A square. If that was an A square, what would be on bottom? Angle A. If that was 1/2 C square, what would be on bottom? Angle C. Okay? So that's what we've talked about so far with the law of sines, the ambiguous case, and our area formulas. What we're going to look at today is the law of cosines, and then what if we know side, 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 and we'd like to find the area of a triangle. Okay? All right. Everything on the board is written down on your the note just handed out to you a while ago. So we'll get rid of that and then take notes on the law of cosines. We're going to use the law of cosines when what we are given is in the order of side, 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 or side, side. If we have a non-right triangle, and what we are given is in the order of side, 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 or side angle side, then we will use the law of cosines to solve. The law of cosines says a squared is equal to b squared plus c squared minus 2 times b times c times the cosine of angle A. A squared equal b squared plus c squared minus 2bc cosine A. Now, let me explain something. This could have been b squared. If it was, then we would make sure that at the end it was cosine b. You understand that? If you start with A, you end with cosine A. If you start with B, you end with cosine B. Yes, sir. Uh-huh. Did I put sine on the paper? Wow. That's cosine. Yes, thank you. Wow. Yes, on this paper I gave you, beside use the law of cosines, I accidentally put sine A in there. A squared equal b squared plus c squared minus 2bc cosine A. Wow. Thank you, sir. That was not good. Okay. It could have been b squared equal a squared plus c squared minus 2ac cosine b. If b squared is first, then cosine b is last. It could have been c squared equal a squared plus b squared minus 2ab cosine c. So if little c is first, cosine c is last, and the middle stuff is a and b junk. If a squared is first, then cosine a is last, and b squared, b and c junks in the middle. Now, if what you know is side, 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 if what you know is side, 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 you don't know any angles. What are you obviously going to be solving for if you know side, side, side? If you know side, 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 you got to be looking for an angle. Now, if you had side, 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 you could find angle A first, angle B first, or angle C first. Right? Wouldn't matter. Which one should you find first if you have a choice? Or does it even matter? Well, let's think about this. We're cosine this time. Cosine is positive in quadrant 1 but negative in quadrant 2. Now, when we were dealing with sine, this is cosine. When we were dealing with sine, sine was positive in quadrant 1, was positive in quadrant 2. If we go to the calculator, it's going to return the smallest inverse sine of the positive. It's going to give us quadrant 1 every time. But cosine is different in quadrant 1 than it is in quadrant 2. It's a different sign. Okay? So if we're in the middle of cosine and we're trying to think about which angle to choose, then we would, because they're different, we would want to try to pick the biggest angle. And here's the reason we would try to do that. Because after we use the law of cosines, we're eventually going to jump back into the law of sines. Okay? We're going to get back into the law of sines. So let's say we picked our first angle. And we said, okay, angle B is 60 degrees. But there were two choices for angle B, because it's got the ambiguous case for law of sines hiding in the background. So it could have been angle B is 60, or it could have been angle B is 120. It's reference angle in quadrant 2. And we wouldn't really know which one it was. And so what we're going to do is make sure we get the big one first, and we can do that by thinking about sines. If we have a picture of triangles, we're going to choose the biggest angle first every time. And that's going to help us. We'll see this as we do a lot in your homework. I'm not going to do as many on the board. But by doing the big one first, it will help us avoid a situation where there was a big one and a small one, and we didn't see the big one, and we missed the ambiguous case situation. Okay? All right. So, on the law of sines, you're going to find the small one first. In the law of cosines, you're going to find the largest angle you can find first. Yes, sir. That is correct. So if you didn't have a picture, but you had that A was 3 and B was 6, C was 10, had sides 3, 6, and 10, if little a was 3, that would automatically tell you that angle A is the smallest because it's opposite the smallest side. That's correct. And if you had that little b was 6, it would tell you that angle B is the medium size because it's opposite the medium size side. So even without a picture, you can know which is the biggest angle because it's the one opposite the largest side. That is correct. And so that was good. I'm glad you threw that in there because I wasn't fixing to say that, and we needed to say that. Very good. Okay. Anything else that we need to add to that or subtract from that? I think we're good there. That's good. Okay, so we're just going to use this form of the law of cosines. We're going to use this form of the law of cosines, and we're going to solve the problem on the worksheet there. Okay, so on our worksheet, we have number 8 and number 9. Number 8 on the worksheet is b equals 7, thank you. Little c is equal to, and big A is 51 degrees. Now, if we were to draw a picture, all we really know is that angle A is 51 degrees. We know little b and little c, and we can just kind of put b and c wherever we want. We'll put c there and b there. It's not going to matter. Little b is 7, and little c is 10. What we have is in the order of what? Side angle side. Now, side angle side really says 2 sides in the included angle of 1 equal 2 sides, right? 2 sides in the included angle. But the way you read it, side, very next, angle, very next side. So it's in the order side, then angle, then side. Therefore, we use the law of cosines. Now, we want to solve it. We want to find everything. So what we want to find is angle A, angle C, little a, little b, and little c. Now we already know that little b is 7 and little c is 10. 10. We already know that angle A is 51 degrees. So what we need to find is little b, little c, little a. Now, we got to think, well, what are we given? What are we given? We're given little c. We're given little b. We're given angle A. You see why I would need the one with cosine A in it? Because it's the only angle I know. I have to use the cosine A version, which means I need the little a to start with version. If I'm looking for angle A, I got to use the one with cosine A in it, so I need the one with little a in it. So that's the version we're going to use, right? And so we're going to say, so what are we going to have to find first? Well, little a. We have to find little a. Now, if we were given side, 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 we'd have choices. When we're given side, angle, side, we didn't have any choice, you see. So we're going to have to find little a. So we're going to say a squared is equal to b, which is 7 squared, plus c, which is 10 squared, minus 2 times a, which is 2 times b, which is 7 times c, which is 10, cosine 51 degrees. Now we're just going to stick it in the calculator and hit enter. But hang on, let's don't do that. Let's don't stick it in the calculator and hit enter yet, because we don't really want to have to get a decimal and try to take the square root of that decimal. So let's just go ahead and solve for a by taking the square root, you see. And so when you punch it in, you're going to have little a is square root of all that stuff, right? And so little a is equal to square root of 7 squared plus 10 squared minus 2 times 7 times 10 times cosine 51. And you get 7.8 for little a. Let's see how we got that. Okay, now what do we have? We've got side, side, side. We could use the law of cosines again. People usually like the law of sines better. Could we switch over to the law of sines now? We've got a side, side angle. Do we have a side, side angle? Yes. Now y'all watch this. This is important. Side, side angle. Now, if we have side, side angle and we're going to switch over to the law of sines, that means we're dealing with the ambiguous case. All right? But we're dealing with law of sines, and so we want to find the smaller angle. Just in case the other one, see the smaller one, the smaller angle can't have an obtuse option. You understand that? There's only one angle that has the option of being obtuse, and that's the biggest one, because there's at most one right angle and one obtuse angle in a triangle. And so we're saying, well, angle 1 is acute, but angle B could either be acute or obtuse, and angle C could either be acute or obtuse. Because what I have now, if I'm going to try to find angle C, is I have side, side angle, which is the ambiguous case. Or if I was going to try to find angle B, I would have, I'm going to make a mess out of that. Well, I would have that. I would have either one. I would have side, side angle, which creates an ambiguous case. And I know that either angle B is obtuse or I know that angle C is obtuse. So I'm going to find the smallest one because I know it can't be obtuse. I know that since 7 is the smallest side, then angle B is the smallest angle. And since 7.8 is the medium-sized side, then 7.8 is the medium-sized angle. And because 10 is the largest side, then angle C is the largest angle. So there's no way B could be obtuse because it's not the largest. So I'm going to find it first because the ambiguous case would not apply. B doesn't have two options. It's got to be acute if angle C is the biggest. You see how we figured out how to find angle B before we find angle C. Okay, so now we're going to revert to the law of sines. And we're going to look for then angle B. And so we're going to say sine angle A 51 degrees over little a, which we just found out was 7.8, is equal to sine angle B, which we don't know, over little b, which is 7. Except I wanted little c. No, I didn't. I wanted little b because little b is the smallest. That's right. I did not mess up. There we go. Okay, so we're going to solve. To solve, we cross multiply. We get 7 sine 51 is equal to 7.8 sine angle B. I want the junk off of sine B, or the junk off of B. I'm going to undo the multiplication by division first, so I'm going to divide 7.8. And so I would have, I'm just going to rewrite it, I would have sine angle B equal, leave some space, 7, I didn't leave enough space, 7 sine 51 over 7.8. I undid the multiplication by division. Now I'm going to undo sine with arc sine. And so I get B as arc sine of 7 sine 51 over 7.8. And I get 44.2 degrees. Thank you. 44.2 degrees. See, if I'd have tried to find C first, I could have gotten an angle that doesn't work. And I'd have wasted some time trying to get an angle that didn't work. And then I have to say, well, let's try again or something. Okay. Now, angle C is obviously 180 degrees minus angle A minus angle B, which would come out to be 84.8 degrees. And so we solved the triangle. We started with the law of cosines, and then we converted to the law of sines, and then we went to the sum of the angles of a triangle is 180 degrees. Any questions on that? We avoided the ambiguous case by finding the smaller of the two angles left, knowing that it only had one option. That is correct. Yeah. So if you do, yeah, if you choose to find the smaller angle, then you can avoid the ambiguous case possibility. That is correct. Any questions on number 8? Okay. Number 9. I'll write that formula back up. Okay. Number 9, we have A equal 4. B is equal to 5, and C is equal to, is it a 7? Okay, so we've got the law of cosines. Our law of cosines, before I write that down, which one do we use? With the A square first, B square first, or C square first? Which angle do we know? We don't know any of them. Okay, this is important. That means we could use any of them because we're going to find an angle first. But if you're using cosine, we want to find the largest one first. This is important. Let me show you why. Cosine is positive here, and cosine is negative there. Now, you know what's going to happen when you throw all those numbers in there? A squared equal B squared plus C squared minus blah, 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 blah. Cosine A, you'll do inverse cosine A equals something. If you choose the largest one and it's obtuse, all of that junk's going to be negative. Inverse cosine of stuff is negative. Okay? If you're not sure what I'm talking about, I'll show you in a minute. If this one doesn't come out that way, I'll make up one that does, because we'll need that example. So here's what we're going to do. We're going to say, in case one of the angles is obtuse, I want to find it first. Now, there can only be one obtuse angle in a triangle. And if there was going to be an obtuse one, which one would it have to be? It would have to be the one opposite the largest side C. So angle C is the only one that could possibly be obtuse. If it was, when we solved in a minute, we would be doing inverse cosine of some negative thing. If we don't have a negative thing, it's not obtuse, you see. So just in case it was obtuse, we would want to find it first. So we're going to look for C, the largest angle. So we're going to do the C-square version. C squared equal A squared plus B squared minus 2AB cosine C. We want to find the largest angle first when we're using cosine. When you're using sine, you want to find the smallest angle first. Okay? So we're going to have C, which is 7 squared, is equal to A, which is 4 squared, plus B, which is 5 squared, minus 2 times A, which is 4, times B, which is 5. That's a times 5. Cosine C. Now, is that if we just move some stuff over? Let's do this. We don't want to do any calculations until we have to. We're going to have 7 squared minus 4 squared minus 5 squared is equal to negative 2 times 4 times 5 cosine C. I'm not going to do any calculation. So we moved everything that was added over to the other side. You can calculate it and move it if you want. We're just going to move it. That way, there's no rounding possibility ever, okay? And then we would undo all this junk that's being multiplied by division, negative 2 times 4 times 5. I mean, you probably ought to go and get negative 40, but let's just do this for the fun of it. And those would cancel. And then you would do inverse cosine of that, right? Now, let's just go ahead. Let's just go ahead and get that number right there just so we can see what it is. This stuff in here, somebody give me what's in the parenthesis answer just so I can talk quadrants again. 7 squared is 49 minus 16 is 33 minus 25 is negative, or 33 minus 25 is 8. 8 over negative 40. So, or negative 20, negative 40. 8 over negative 40, negative 2/17. We got lost. Negative 1/5, negative 1/5. Okay, so this is actually a negative what in here? Negative 1/5. Now let's talk about that. It's a good thing we did this. This was the example we wanted. Negative 1/5. If cosine is negative, where are we at? Quadrant 2, which means angle C is obtuse. It is the obtuse one. So it's a good thing we found C first. You see? We're going to find the biggest one first. What's going to happen is if it really is obtuse, then that's going to put it in quadrant 2, which means what's in there is going to be negative. You see? And the inverse cosine of a negative 1/5 came out to be what? Second cosine negative 1/5. What do you get? (101.5). Now, in my answer, I have 101.7 because I rounded a bunch, you see. Threw me off 0.2 degrees by not doing it like that. You see why we want to find the largest one first in cosine and why that sign makes a difference and where it's going to show up in your work, okay? This I want to show this again. If we solve this stuff in here, all this stuff in here turned out to be a negative, and we're saying we want the cosine, we want to know what angle has a cosine of negative something. If an angle has a cosine of negative something, and it's between 0 and 180, it means it's going to be in quadrant 2, so it's an obtuse angle, 101.5 degrees. Okay? Now, we know the other two have no possibility of being obtuse, so now we can just find the others with law of sines. Okay? And so we have found angle C. What we need now is angle A and angle B, right? We knew the sides, so now we need angle A and angle B. Well, to find angle A and angle B, we can use our law of sines now. Now, what we know both of is C. So we're going to say sine C 101.5 over little c7 is equal to sine A over little a4. And we can solve for angle A. So we're going to cross multiply. We'll have 4 sine 101.5 is equal to 7 sine A. Get the junk off of A. We're going to undo multiplication by division first. And we will have sine A equal 4 sine 101.5 over 7. I didn't leave enough space again. Always forget to leave space for my inverse, my arc. So now we're going to undo sine with arc sine. So we do arc sine, 4 sine 101.5 over 7, and we get 34.05, 34.1 degrees. So to get angle B, we do 180 minus angle 1 minus angle C, 101.5. And we get what for angle B? 44.4 degrees for angle B. Any questions on the law of cosines? When we had side angle side, we didn't have a choice of what to find first. When we had side we did have a choice of what to find first. And we found the largest angle first. So when you're using law of sines and you have a choice, what do you choose? To find the smallest angle first. If you're using law of cosines and you have a choice, what do you choose? Find the largest angle first. Any questions on that? All right. In this lesson, we have one more thing, and that's another area thing. We summarized a while ago, and we said if we're looking for the area, and what we are given is in the order of side angle side. I'll get this right in a minute. If we're looking for area, and what we are given is in the order side angle side, what formula do we use? Where A is the angle and B and C are the sides, right? If what we're given is in the order of angle side, and we want the area, then our formula is K equal and we know that whatever that letter is going to be the angle on the bottom, right? And we also know that that letter and that angle are those two things right there because they're opposite each other in the picture. Okay? Just happens to be that way. And so we're adding a new one. Our new one is side, side, side. If you know all three sides of a non-right triangle, you can find the area using Hero's formula. Now, I saw this written as Heron's formula long ago when I was teaching. So I've seen this called heroes or herons. I'm not sure which one it's supposed to be honest with you. But anyway, uh, hopefully they got some credit while they were around to appreciate it. Anyway, uh, side, side, side. And so we have area is equal to the square root of semi-perimeter times semi-perimeter minus side A times semi-perimeter minus side B times semi-perimeter minus side C, where S is equal to 1/2 of the perimeter, which is the sum of the sides A, B. So if you know all three sides of a triangle, you can find the area of that triangle using Hero or Heron's formula, which is area equals square root of, we call that the semi-perimeter because it's half the perimeter, semi-perimeter times semi-perimeter minus side A times semi-perimeter minus side B times semi-perimeter minus side C. Okay? And the example that we have first is number 10, which says little a is equal to 4 and little b is equal to 6 and little c is equal to 8. So the first thing we would need to do is find the semi-perimeter. The semi-perimeter is half the perimeter, which is half the sum of the sides. 4 plus 6 is 10 plus 8 is 18. Half of that's 9, so we calculate that the semi-perimeter is 9. So we find S first, the semi-perimeter. I'll let you catch up. We said we got that? Everybody ready to move on? So once you get that, then you throw that into your area formula. Area is equal to square root of semi-perimeter 9 times semi-perimeter 9 minus the first side 4 times semi-perimeter 9 minus the second side 6 times semi-perimeter 9 minus the third side 8. And we'll stick that in the calculator and hit enter, and we get 11.6 for the area. Any questions on number 10? Okay. Finding the area of a triangle given the sides only. Okay, they got that? So we'll do number 11. Number 11, we have A is equal to 20, B is equal to 30, and C is equal to 40. Now, before we go any further, let's talk about it. Can that even be a triangle, and how do you know if it could even be a triangle? To be a triangle, it has to be true. The sum of the smaller two sides has to be greater than the larger side, right? And so 50 is greater than 40, so yes, it is a triangle. We need to remember that in the back of our mind. Anyway, hopefully we wouldn't try to trick you on a test. So we get semi-perimeter. Semi-perimeter is 1/2 the perimeter, which is 1/2 of the sum of the sides, 20 plus 30. Now, if you were in geometry class, I'd try to trick you because I'd make sure you knew your geometry. But anyway, so we're going to have 20 plus 30 plus 40. 20 and 40 is 50 and 40 is 90, and half of that's 45, so the semi-perimeter is 45. Half the perimeter. So once we have that, we plug it into the formula. So we're going to have semi-perimeter 45, times semi-perimeter 45 minus the first side 20 times semi-perimeter 45 minus the second side 30 times semi-perimeter 45 times the third side 40 and we get that the area is equal to 290.5. All right. Thank you. Any questions on lesson 30? So lesson 28 through 30 in our pre-calculus here at Prairie Land is law of sines ambiguous case, law of cosines, and special area formulas. And what we're doing is solving non-right triangles and finding the areas of non-right triangles. Any questions on any of that? All right.